So we are going to review trig ratios here, sections 8.2 and 8.3. Do you recall what is the popular acronym that we use? SOCATOA. And again, make sure you have your diagrams that could be helpful to you. So when we use we have the opposite and hypotenuse for sine. Cosine, we have the adjacent and hypotenuse. And tangent, we have the opposite and adjacent. Again, that's all with relationship to the angles. Okay. It might help you to make sure you twist your triangles every once in a while too. So for example here, if I have an upside or a different triangle here, and I'm doing this angle, well, sine is now here and here. Cosine is now here and here. And tangent would be there and there. So again, make sure you kind of look at how your triangle is faced so you identify. Always remember the hypotenuse is always the side that is opposite of the right angle. Hypotenuse is always the side opposite of the right angle. That is important to remember. But again, here are the trig ratios, and the famous acronym is the SOCATOA here. First thing we're going to look at today is you can remember the trigonometric ratios by using a mnemonic device. Does anyone remember the most popular mathematic mnemonic device? What is it? PEMDAS. Please excuse my dear Aunt Sally is a mnemonic device. Now, you can make up a mnemonic device. Most people just say SOCATOA. Kind of is a popular thing within itself. But if you look here, such outrageous hats can attract horses, tigers, or alligators. Now, it'd be cooler if it was like lions, tigers, and bears, but it's not. So.
Did you create that?
No, I did not. I'm not that genius. But they have horses, tigers, or alligators. And again, here's the important thing. There's the ratio. Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is the opposite over adjacent. Okay. So again, recognizing where you find these. Again, if you have to use the arrows, I like using arrows sometimes. For example, angle B. If I'm going sine, I'm going to the opposite, then hypotenuse. Okay, so you kind of visually see where you're going. Cosine is adjacent and then hypotenuse. And then tangent is opposite and then adjacent. So recognize those different angle measures and the different trig functions. Same idea here. We talked about this yesterday, but this is helpful for solving. Anytime we're doing these functions here, you always want to make sure you do have SOCATOA written somewhere on your paper. If you have the triangles diagrammed, it might help you as well. Now, whenever I have a right triangle and I am given two sides, what is the best way to probably find that third side? It is to use the Pythagorean theorem. That would be the best way always to find that third side. Okay. Now, on a problem like this, they're finding A. Well, I only know the opposite and adjacent, so I have to use the tangent inverse function to find my degrees. And then once you find two of the degrees, you can always subtract from 180 to find your third degree. And on a problem like this, you only have to technically use trig functions once, and you can find everything you need to know about that triangle. Okay, that is important. You don't always have to use trig functions for everything. There's a lot of different things about triangles that we've already learned you can still recall. So on these 6 problems, it's asking you to find which angle it is. So for example, it says, use the given trigonometric ratio to determine which angle of the triangle is angle A. I have 2 angles. I have angle 2 and I have angle 1. Each one of them will be either angle 1 or angle 2 as an answer. Take a couple seconds, solve these 6. Alright, so let's look through this here. Number 1, which angle would give me the sine that is 8 over 17? Now remember, sine is opposite over hypotenuse. So basically what this is saying is which angle has the opposite side that is 8 and the hypotenuse is 17? That would be angle what, Caprio? Which one? 1. Angle 1. Nice job, sir. You get angle 1 goes 8 and then 17 for sine. Number 2, which cosine has the ratio that is 15 over 17? Noah? Angle 1. And cosine's adjacent hypotenuse, that is angle 1. Number 3, which tangent has a ratio that's 15 over 8? Bryce?
2.
That's angle 2. Because 15 is opposite, 8 is adjacent of 2. That gets me angle 2. Number 4, which sine has a ratio of 15 over 17? Drew?
2.
Angle 2. Number 5, which cosine has an angle of 8 over 17? Ryan? Angle 2. And lastly, number 6, which tangent has an angle that has a ratio of 8 over 15? Frosty? Angle 1. Nice job, sir. Next 6, using your calculator, find each angle measure to the nearest degree. Recognize we are using the inverse functions, so make sure you hit the inverse function and find these answers. All right, let's go through these here. Number 7, sine inverse of 0.82 gives me what degrees, Tyler? Number 7? 55 degrees. Good work, sir. Number 8, cosine inverse of 11 over 12. Keegan gets me what degrees? Ryan? 24 degrees. Number 9, tangent inverse of 5.03 gets me how many degrees, Nick? 79 degrees. Number 10, sine inverse of 3/8 gets me what, Johnny? 22 degrees. Number 11, cosine inverse of 0.23, Gabe? 77 degrees. And last but not least, number 12, tangent inverse of 1/9, Frost? 6 degrees. Nice job. All right, now we're going to take all of that information and we're going to use it to help us solve for the measures here. So number 13 here, find the unknown measures, round lengths to the nearest hundredth, and angle measures to the nearest degree. So lengths to the nearest hundredth, angle measures to the nearest degree. Now number 13, what can we probably find right away that does not use any new information, Troy? I can find the hypotenuse. What do I use to find the hypotenuse, Troy? Yeah, I can use Pythagorean theorem and solve for AB. So for instance here, 4.2 squared plus 6.5 squared is going to equal AB squared. Using your calculator and Pythagorean theorem, solve for AB. Now remember, the last step of Pythagorean theorem is always to take the square root. Okay. Did you take the square root? What'd you get? Huh? No. No. That's wrong. The correct hypotenuse is what, Troy? 7.7. Nice job. Now, using this information, I need to now find one of the angles. Which angle would you like to find, Johnny?
Which one are we on? 14?
13.
Oh, okay. C.
We already know C. C is 90 degrees.
Oh wait, never mind. I'll find A.
Let's find A. Now, we're going to find A.
I know where we were.
Johnny, which trig function would you like to use to find A?
Let's go cos.
Okay, so we're going to use the cosine. Now, because we're using cosine, which two side lengths do I need to use then? If I'm using cosine to find angle A, I need to use what two side lengths, Martina? Adjacent hypotenuse. So I use 4.2 over 7.7. So do cosine inverse of 4.2 over 7.7. Cosine inverse of 4.2 over 7.7 should give me an angle measure of what, Camden? 57 degrees. Nice job. Now, depending on how you round, you could always be off like a degree from what somebody else has, just depending on how you round, because it makes the calculator round differently. So do understand that. But if angle A is then 57, can I find angle B? What do I do to find angle B? Yeah, subtract from 180. So 180 minus 90 minus 57 gives me angle B is what, Jack? 33 degrees. Number 14. What can I use to find EF? What is the first thing I can do on a problem like number 14 and find EF, Bryce? Pythagorean theorem. But I am given the hypotenuse. Does everybody see that? So I need to subtract. Nice job. So it's now 3 squared minus 1.25 squared. And that will come out to be EF squared. And again, remember, always the last step is to take that square root. So 3 squared minus 1.25 squared. And then take the square root. And I get EF to come out and be what, Caprio?
2.7.
To 2 decimals, please.
2.73.
2.73, nice job. Now I have all 3 sides. Now I can find any angle I would like. Boger, which angle would you like to find? D. Noah, which trig function would you like to use to find D? Cosine. So I'm going to do cosine inverse because I'm trying to find the degree. Noah, what 2 side lengths do I need to use then for cosine of D? Very good. So 1.25 and 3 because I need the adjacent and the hypotenuse. So I'm going to do cosine inverse of 1.25 over 3. And angle D comes out to be what? Nick, what did you get? 65 degrees. Which means angle F has to be what then, Frost? $25 degrees. Nice job. Now again, on both those problems, I only had to use trig functions once. Other than that, it was all prior knowledge that I've used. Okay. Number 15. What can I find right away on number 15, Tyler? No, I already know G. Angle, oh yeah, I think it's a J, but yes. What is angle J, sir? Yeah, because it's a triangle, I can find angle J right away, 180.
That is in the right corner.
That's 46 in the right corner.
Yeah.
So angle J is what then, Tyler? 44 degrees. Okay. Now I'm going to have to use some trig functions to solve for IG or GH. What would you like to use to set this up, Peyton?
What?
How would you like to set this one up to solve for either JG or GH? I can use a lot of different methods here. I cannot use tangent because I do not know either the opposite or adjacent.
Sine 46 equals
Very good. Sine of 46 equals x over 11. What side length am I finding then if I do sine of 46 equals x over 11? I am finding JG right there. So I do sine of 46 equals x over 11. And JG comes out to be... Anybody? That is, I believe, correct. 7.92. Now, how can I find GH? Anybody? I can do Pythagorean theorem. Or I could use sine functions. I already have sine set up, but instead of 46, I'm going to do sine of 44 equals x over 11. Because sine of 44 is the opposite of 44 is GH now. And then I can do that as well. Again, that might be a little bit shorter than Pythagorean theorem, but if you want to use Pythagorean theorem, go for it. Either way, you should still get approximately the same answer. Because GH is approximately what, Caitlin? 7.7. Just quick, so I think it's like 7.70, right?
Yeah.
What's that? All right. Try these three problems. Okay. Using these same methods, solve for the missing side lengths and angles. Take some minutes here and try these. Number 16 here. What's the first thing to find on number 16, Drew?
You find angle for
Angle what?
K.
And what's angle K? 17 degrees. Nice job. Now that I have angle K, I can find one of the other two sides, but I have to use trig functions. Which one did you use, Caitlin, and how did you solve it?
I did cosine for 73
Equals?
0.83 over x.
Nice job. Cosine of 73 equals 0.83 over x. Now again, recognize, you can set these up a lot of different ways depending on what you've done. I could have done sine of 17 equals 0.83 over x. Okay, either way, it doesn't matter. You got to make sure you're setting it up with the correct trig ratio. When you work that out, what's kj come out to be then, Caitlin? 2.77. Is that what you said? Okay. And then what'd you use to find KL, Caitlin?
Sine 73.
You did what?
What?
You did, sorry, say it again.
Sine 73
Equals?
x over 2.77.
Nice job. And that comes out to be?
2.70.
2.70. Now, depending on how you rounded some of these answers, you could always be off by a couple of decimals, and that's all right. All right, just depending on how you round. Number 17. What did you get for QP, Nick Caprio? What's QP come out to be? Troy? What's QP come out to be? Follow along here.
I have QP, but I don't know.
Well, I'll just go to
Oh man.
Mr. Jack here. 11.18, thank you. Because I think it comes out to be like the square root of 125, right? Square root of 125 is 11.18. Now I have to use one of my trig inverse functions to find an angle. How did you find an angle, Martina?
I didn't find an angle. I didn't understand that part.
Give me an angle. Which one do you want to find? Okay, what trig function do you want to use for Q?
Sine.
Okay, so I'm going to use sine inverse.
Oh, it was the inverse one. That's why I was
Anytime we have angles, we use sine inverse.
Sine inverse. Let me get the sine inverse
10 over 15. So I do sine inverse of 10 over 15. Yes, basically 2/3. Sine inverse of 10 over 15, what's angle Q come out to be, Caitlin?
Yeah, 42.
42 degrees?
Yeah.
Which means angle R has to be
48.
48 degrees. And lastly, number 18. What can I find right away, Bryce?
Angle S. We know the ST.
What is ST?
3.57.
How'd you find that? Yeah. 3.5 squared plus 0.75 squared equals ST squared. Nice job. Now that I have that, I can find any angle I want to. What angle would you like to find, Ryan? Huh? Okay, and how do you want to find angle T? Cosine? So cosine for angle T means I'm going to need what ratio? What side lengths? Yep, 0.75 over 3.57. Because that's adjacent over hypotenuse. And then when I do that, I get T equals what degrees, Ryan? So cosine inverse of 0.75 over 3.57. Anybody, what's angle T come out to be? 78 degrees. Which means angle S is then how many degrees 12 degrees. Nice job, Drew. Again, there's not necessarily a lot of trig functions you have to use. When you're finding degrees, you have to make sure you remember to use. Degrees, you have to use the inverse function. When I'm finding side lengths, I have to use the other functions. Here is your assignment.